we will start the second session, and our first speaker is our invited speaker, Veronika Zwatz-Meise. Ping has briefly introduced her before. I will just add a few more things that seem to me very interesting to mention. Veronika has developed the Satellite Meteorology and Remote Sensing department at ZAM. And I must say that a lot of forecasters here look into the products that are there not only in the Met Office, also in the Air Force, at university. I'm very, very aware of it. And she has many cooperations with EUMETSAT in several projects. And she's also lecturer in satellite meteorology at the University of Vienna for about 15 years. So please.
So first of all, thank you very much for this introduction, and thank you very much for the invitation to be here. I had already challenging days and challenging discussions, and I must say that I like the atmosphere of this workshop very much, and I hope that I can a bit contribute. It's now the remote sensing area, and the content will be milestones from the past, a very short introduction, then the present status, and then the future, what will we have available from the satellite generations, and what will be the demands of the from weather forecasting. Also here something will change. And in the end, what will be also necessary for in this area for keeping knowledge alive and practicing, training and practicing. I have to confess in the very beginning that there are some boundary conditions to this presentation, because it could be a very general presentation, of course. The boundary conditions are remote sensing data for numerical models. This is something which is an ongoing and very important job, and it will lead to the improvement of numerical models, but it's not what I will treat here. It belongs more to the numerical model person, and I think it's also not what you thought that I should present here. The weight lies on satellite data, not so much on radar data and spherics. I have seen in the program you will also have a radar presentation later on. And I must also confess that the presentation is, of course, because of my area where I am living and working, a bit Europe and EUMETSAT biased. But if I speak of Europe, I speak also of the neighboring countries of the Mediterranean Sea. Now the milestones from the past. This is a personal experience. MFG, Meteorsat first generation, the first generation of geostationary satellites, had two big steps forward. The one was a new channel, the water vapor channel. And it needed a relatively long time until we learned to work with this channel. But at the moment when we really introduced it, it gave us new insight in the atmospheric, stratospheric processes, and really gave us new ideas of conceptual models. And when there was in the first part the discussion about the jet and the influence and about what you have in your lectures from satellite meteorology, from satellite report, there are lots of examples where you can make these interactions visual, and the water vapor image is one of the most important steps in this direction. We learned really quite a lot. The second point is second step is a more practical one. Because of this high time frequency, which was the first geostationary satellite in Europe, we could compute the cloud motion vectors, the atmospheric motion vectors, and this was the first big step in operational nowcasting. And my institute and in my department, we started very early in nowcasting models based only on this remote and satellite data in the first instance. Then the second generation came, Meteorsat second generation. We had new and many more channels, and for me, the big step, as far as I can see it now, was this intensive work on RGBs, on difference enhanced images. I must say that RGBs were nothing new. They were already from the very beginning of satellites available, but the understanding and the best possible RGBs were developed in these last years after the launch of MSG, and they brought also new insight. They brought new insight in inherent physical structures of cloudiness. And if you look into this is more in the synoptic and mesoscale. And here we are now in the meso and in the very small scale. And from this concept of SAFs, Satellite Application Facilities, and MPEF, which is the central production facility at EUMETSAT, the first products were computed. And a very important topic is convection, and also for convection there was quite a lot of RGBs, of qualitative structures, but also of products developed. Now, I want first to start with the state-of-the-art of available images and some products, only looking as a forecaster into an image or into a product. You see, I will go to RGBs. I will also go to synthetic satellite images and their use. I will go to parameters of the SAFs, and then I will also show you some of the METOP parameters. Now, this is a summary of a computer-aided learning module in a training project, UmiTrain. And this summary shows you that in the end there are not so many RGBs as was in former times. In former times, metrologists looked into pictures, into colored pictures, and very often did not know what they mean. Now we have an air mass RGB, the dust RGB, and the microphysics RGB. There are some more, but as we found out that with these 3 RGBs, you really can make as a forecaster quite a lot. And what you see here is for which synoptic situations you should use which RGB. Something very practical, but a very big step for a forecaster, not looking into one of the other pictures, but knowing why you are looking into this. And you can also see the other way around. You can also look what RGB can help me if I have some questions in cyclogenesis, some questions in convections, and in low cloud. And you see here also a big part which I think is also something which arose quite a lot with Meteosat second generation: vegetation, forest fires, and land use. Now, this is a very spectacular image, an enhanced image from the topic of convection. Quite a lot of institutions and of working groups are working with this. I have only mentioned some very close around Austria, the Czech Republic, the Croatia and Slovenia, and the Convection Working Group, in which also Daniel Rosenfeld, I think, is one of the leading members. And what you see here are very impressive images, but it's an image. A forecaster can look into it. It's an image where you can work on it. But as I will come back to this image a bit later, we need as a forecaster in a working process a bit more than this image. This is also an RGB, but this is an RGB from a synthetic image, computed from ECMWF data, and an actual image. And it can be used to get a quick overview how well the model is acting at this point of time of the image. So you see red, you see white areas, you see red areas, you see more blue areas, and they show where there are deviations between the synthetic images and the actual image. Again, it's an image where you can look at, and a bit later I will show you how you can use it in a metrological process. Now coming to the products. One of the concepts of EUMETSAT are the SAF, Satellite Application Facilities, where in member states where there was quite a lot of know-how, products concerning to topics of metrology were computed and are also delivered. We have the nowcasting SAF, where I will show you some examples. We have the ocean and sea ice SAF. We have the ozone SAF, the land SAF, and the hydro SAF. And we have some, they are creating a lot of products. I cannot show all of them. There are about 200 products or something like this. But there are also the NWP and the GRASS SAF, where the satellite data are used for numerical models. Now, I want to concentrate on this nowcasting SAF. This is the output of products. and I will show you one of the most popular one, the cloud classification, the cloud types. You can see here in the different colors, different cloud types computed from an intelligent combination of all these channels which have the physical status of the clouds inherent. So for instance, if you're looking at this yellow here, you can compare and you see this is cumulus cloud, this is a higher cloud, this is a higher semi-transparent cloud, and together with the height, you have a really quantitative evaluation. You see, for instance, here that this cumulus cloud is somewhere about 5,000 meters, while this higher one is about 9,000 meters. Convection is a very important topic for many, many countries. I guess it's also a topic here. And one of the most important things is the pre-convective environment, to know about convection before it really develops. As soon as it has developed, we have enough methods to deal with it. And there is again some of the products which is available from EUMETSAT. It's the Global Instability Index, or as it is here, the Regional Instability Index. And what you can see is an investigation for Austria. These red lines are the contours of Austria, also a small country, so I know the problems of weather forecasting in the small countries. And you see that in this case there is, with the blue colors, a slight instability in the morning, which becomes a bit higher at noon, and some hours later there is a lot of convective activity seen in the lightnings and also seen in the radar, and there is also hail. This is again a product where, if you look at it, gives you a first impression, gives you an additional tool to what you already have from the models. Also, this has to be said. But as you will see, it's again a mesoscale. It's this area, which is a mesoscale area. It's not enough to go into local forecast. Now, some products of METOP. And I must say that there are quite a lot of products which should be useful for forecasters. I must confess that the real important use in forecasting has not yet been done. What we in my institute, again you see the contours of Austria and the capital towns, we have available all these vertical cross sections from the IASI instrument. But also, to be honest, that's it. The forecasters are looking into it, and there is still missing a further method, model to include it into something which can give you a bit more. And I know I spoke with many NMSs in Central Europe and also Western Europe, and it's more or less everywhere the same, and there are also a bit doubts, problems with the quantitative values. Another product which may also be for the Mediterranean important are the winds from the ASCAT instrument. And I can show you a case study, the case of Xynthia. This was a rapid cyclogenesis southwest of Europe with a path to the north and with a lot of damage there. And what we wanted to look at is how can the winds help us. First of all, you see that this is was really a very rapid development. And what you can see here are the ASCAT winds. There are also the winds of the Hirlam model. The winds of the Hirlam model are the blue ones, and you see that the ASCAT instrument can give us many more winds. But again, there are some problems, something which has to be prepared in a better way to the forecaster. This is a case study over 3 days, and we found only 2 points of time where there was the path over this situation. Fortunately, already when there was this big deepening going on here. And the second is again that you have to be very cautious with the quantitative values of high wind speeds. So on both things has to be worked, and there will be quite a lot of time in the next years to do it and to introduce it in the same way into an operational forecast service as it is already available for MSG products. Now, this was images and products. If we look at now from a bit different view, the question is, where are satellite and radar data most useful today in a forecast service? Of course, for analysis, of course, for nowcasting, for warnings, and for model error detection, or let me not say model error, it's seldom a completely error, it's model quality estimation. And for which weather systems? Principally all synoptic and mesoscale structures. Very important for those which are very weather active, like the rapid cyclogenesis, like wave development, secondary cyclogenesis, prompt intensification in the left exit region of the jet streaks, something which are the hot spots if you look into a weather chart and looking into derived parameters and images, the hot spots where you really have to concentrate on. But in the smaller scale, it's of course convection. And in my country, and I think in many others, also Western European countries, it's also fog. I don't know if fog is a topic here, so fog is only mentioned here, but there are also quite interesting methods for this. And the land use is something which also, from my feeling, came up much more in comparison to earlier. The forest fire is really something which you can use operationally. The dust is something which I wrote here, but I didn't dare to speak more about it because I'm sure that you know much more about application of this than me. Soil moisture from the hydrosaph. Now, if I go away now from what images are available to where am I using it in the forecast process, then it's necessary to move from images to products and from the images and the products to integrated method and models. And there is already existing something which I will shortly show to you. With MSG we had these first steps in combining the remote sensing data with other data. And the four I want to show you is the satellite report, which is a combination of satellite images with other data, with the conceptual model approach, something which I showed yesterday in the Institute in much more detail. Then there is the integration in nowcasting models. The Inca model will also be shown shortly. Again, yesterday I showed it in more detail. If you combine the two presentations, you have a hopefully fuller picture. The integration in early detection of thunderstorms. Remember that I showed you already a product for the pre-convective environment. And the integration in the warning methods. Now, this is an example for a satellite report. You see that we use already the MSG RGBs, the AMS RGB, and this is how the SATREP as such looks, an international product. In this case, the important point was this situation here, which was one of these very big storms in the last year, which really had a lot of disaster and lot of damage in Central and also North Europe. So what can you see from the SATREP? First of all, here in the thickness-rich cloudiness, this is the abbreviation, you can see that there is pronounced cloudiness, that there is warm advection maximum, that there is already rain and others. This is the cloud feature which is passing before the system came. In this information, you are informed that you should look into this water vapor image, showing the dry stratospheric air, the overrunning dry atmospheric air, and giving also some hint that potential vortici anomalies are there, showing again this interaction of stratospheric and tropospheric situations. And this is some information about the deepest depression and how it will move. This is Central Europe, and this is not the recent SATREP, but what I showed you yesterday in much more detail. With visualizations, our new visualization systems, we are also able to go far more to the east, and we can also make SATREPs for this eastern area, for your country. And yesterday I said already that this is an international project. We want to put the SATREP together from mosaics. And again, an offer from my side, and a hope from my side that you are interested in this and will work together, the more that you are now members of ECMWF. Now, this was the image which I showed already to you. How can you really use it? Again, when you combine it with relevant parameters. So what can we see here? For instance, if you look into this red and this blue or cyan a line here, this is quite typically for fronts and nothing too dramatic here. It doesn't mean anything else than the front is quicker than in ECMWF expected. I think I forgot to say that the red areas show that in reality there are more clouds than forecast from the model. That means they are quicker if you have these two parallel lines. So this is something which you see quite often. I don't know if it's really a very dramatic thing for the forecasting, but if you look into another region, into this one, then it's much interesting because there is some cloudiness available or existing or developing, which is not forecast in the model. Now, what comma-like cloudiness in ECMWF underestimated? So how can you introduce it in your forecast? Because it's easy to say, if you look into the images, the model is wrong here. But I don't think that this is every time the right answer, because this is a three-dimensional process, and you're looking into a two-dimensional image. So it's not so easy. You have really to think about how you can evaluate if this is a model error. So what you have here is now the ECMWF. Let me start here. The ECMWF 18-hourly forecast and ECMWF analysis from temperature advection. And if you look into this area, you see that there is really a big difference between analysis and 18-hour forecast. That means in this case, there seems really to be an underestimation of the process because we have warm advection and cold advection. We have only cold advection here. And if we look into another parameter, into this vorticity advection, into the positive part of the vorticity advection at 300 hectopascal, again, we are looking into these upper levels. Again, here you see between the forecast and the analysis a big difference in the intensity. So these are studies which are underway in the UMI-TRAIN project, which I'm coming in the end. What I think it's possible to find also conceptual models of model errors so that you can be more sure that this is really something where you have, where the model is not correct, or against others where there are deviations, but it's only a question of three-dimensional processes. Now this was the satellite report, this combination of satellite images, satellite products with derived model products. This is something which is partly manual. It is something which is not automatically done at the time being, but there is also some investigation, or there was also some investigation in our institute to evaluate structures in satellite image automatically. There is also an automatic SATREP available, with all the problems we experienced in this, I think, 4 years' work. Now let me come to the next point, the integration in nowcasting models. INCA is integrated nowcasting through comprehensive analysis. And the idea was to combine this knowledge of nowcasting from remote sensing data and the knowledge of model data, and to have a model which comprises the NWP forecasts from a LAM model, the surface observations, the radar, and the satellite data, computed on a high-resolution topographic data. And this is the outcome. You have a spatial resolution of 1 × 1 kilometer. You have, for precipitation, we started with 15 minutes for precipitation, 1 hour for temperature and humidity. We are changing now even to 5 minutes for precipitation and for gusts, as we have to be quicker and as we have to be more in time. Now, there is quite a lot of input, and what I want to concentrate now, yesterday I showed this model in more detail, is where, at the time being, are the satellite data included. Of course, in the cloud analysis and in nowcasting. What we are doing is that we downscale the MSG cloud types, which I showed you before on this grid, and then we scale it by the observations of our station of the sunshine duration, and we can also do it in the night using the corresponding starlight fraction. The nowcasting is coming from the cloud motion vectors on visible and on infrared images, and the extrapolation is done up to 6 hours. And this is how the situation is. This would be only a cloud chart from the observations, and you can very clearly see where there are stations located. These are the cloud types. Different ways of presentation of cloudiness, so you have to scale them. You have more or less to scale them in terms of this percent of sun duration, and then you get the best possible cloud image. And this can again be used for nowcasting, for a better nowcasting of temperature, for a better nowcasting of global radiation and other parameters, which I have shown yesterday. Okay. So this is at the time being the only parameter which goes into this product. This will change dramatically in the next years with improvements of, for instance, temperature from satellites and with the next generation. And this is now a part of INCA. It's again convection and initiation of convection. And again, we have an expert system, an integrated system. This was where we started with many typical convection parameters and with many parameters from satellites. And it turned out that these CAPE and SYN, moisture convergence, are the most important parameters. All the others you can forget at the time being. And from satellites, at the time being, we are using the visible satellite image showing the first sign of something going on, and the cloud types from satellite. Again, you will see that we hope that this will change dramatically a bit later. Now, this is an example to show how this works. If we have a precipitation analysis with this yellow-blue areas, there is no precipitation here. But if you look now into these parameters, if you look into moisture convergence close to the surface, by the way, you see that there are many areas, but this one is also an area. If you look into CAPE and into the visible image, you see that exactly here where this cross is, all the highest values fit together. And this means that in the forecast 1 hour later, you have some precipitation from this correlation of these parameters. And if we compare with the analysis, this is even more. This is a way which is down to a scale of the valleys in Austria. If you compare with the Global Instability Index, it's a very good tool for the beginning of a general forecast. But it's not a tool for where exactly will it be. This will be a tool where we include satellite data, and you will see in future more satellite data. And again, we are coming now to warning. A warning tool for thunderstorms, an automatic nowcasting tool. Thunderstorm warning is something very, very critical in many regions, especially also in Austria. If there is an unstable situation, you have hundreds of thunderstorms. You have changing thunderstorms every 5 minutes. So if you really would warn for thunderstorms, you would need hundreds of forecasters. So we tried to make this automatic tool, and I can say that it was a success from all the evaluations we had. We are using the automatic hail probability detection from the Swiss colleague Waldvogel, adapted to our country, and we use the automatic extrapolation, which is coming from radar or coming from satellite. Now, the first step is the thunderstorm analysis, and at the time being, we are mainly using lightnings, and this is the area. This is a gust line where we have this crowding zone of the lightnings. If we now want to have an hail analysis, we need radar data, not only the two-dimensional you can see here, but we have to go in the third dimension. This is a cross. This line here is this cross section, and we are using the method where we look how thick and how intensive the radar signals are above the freezing level coming from the models. And you see, for instance, in these areas that there are very intensive radar signals and very thick ones. And if we really apply to this, these are the areas with a very high hail probability. So you see, in this case, three-dimensional radar model data, not yet satellite data. But in the next step, this is now the nowcasting, we need both. We need the radar motion vectors. I know that this is not seen very well. You see these are the computed radar motion vectors from the last 10 minutes computed into the future. But we need also the cloud motion vectors or the atmospheric motion vectors, mainly for having two systems in parallel. If something is going on with the radar, some failure is going on in the radar, we can use the atmospheric motion vectors and the satellites. And this is now what the meteorologist sees, what the system sees. This is the picture of it. For instance, here in these shaded dark areas, these are the areas where you have actual thunderstorms or where you have actual hail. And this is the forecasted path for the next, let me say, 45 minutes or hours. It can even be longer. And as soon as if there is a customer, and we have hundreds, thousands of customers, is in such a path in the future, he gets automatically an SMS message, an SMS warning, and he can look into internet portals and he can get more information. Okay, so you see here are the satellite data included in the system, only the quantitative value. And I'm sure that this will change in the future dramatically. That means I will come back to this a bit later. Now, the future, 2010 to 2020, what satellite generations will be available? And again, I have to confess that I concentrate more in the area which I know a bit more. Now we have MSG, we have METOP, and the partners from US, the NOAA satellites. There will be soon JASON, especially important for sea. And MTG, Meteors, third generation, with two different satellites, an imager and a sounder satellite, will be launched earliest 2017. It will normally be later, but this is something which I will not express in this during EUMETSAT, but everybody knows that this is the earliest possibility which we try to hold. METOP follow-up, post-METOP is even later, not in this period. Therefore, I'm concentrating on what we have and concentrating of what will be available in the last, let me say, 3 years. And I think what you can see from this, during the biggest part of this period, it's still MSG, METOP generation, and the corresponding and partner US polar satellites, some of them launched very soon. So it makes sense to look what we have reached already now and to develop this further, to integrate it so that we are on a very high level when MDG is coming. And what will MDG bring us? MDG will, of course, have technical and radiation improvements, especially if you look into this. You will see that all the nowcasters are very happy about this. We have 1 to 2 kilometers, the full pan of 10 minutes. We have less than 1 kilometer, 2.5 minutes. And we have also improvement in the channels. This is, of course, something which can be used immediately if we are already relatively high with our methods. But there will also be new services. There will be these vertical soundings from the sounder instrument. There will be lighting from satellites continuously. And there will be this chemistry part, aerosols, trace gases, which I'm sure that in the future, although I do not have any examples for this, in the future will also play a role in the forecasting. This is only to mention it. And there will be new products. It's a bit too early now to show and mention you new products. It will be the preparatory phase of the MDG, where there will be quite a lot of evaluations, quite a lot of research in these new projects, in these new products. Now, analysis and nowcasting will profit mainly from this higher time and space resolution, from the lighting mission, and from the sounder instruments, because what I hope and what everybody hopes, there will be really quantitative output for looking for combining it with CAPE and with SYN. And what are included also here is warning, and there are warnings which go a bit beyond the classical warnings of storm and precipitation. Volcanic ash, we had an example and I will show it a bit later. Dust storms, this is something where I'm sure that there is already something going on. Forest fires with the quantitative products from the SAFs, and trace gases. I could make a question mark here, but I'm sure that there will be some needs in future in the forecasting. Now, this was MFG and MSG, and what do I think, what is the expected way forward for MTG? The transition from single channels to products, product combinations, and the transition from qualitative to quantitative evaluation, and the inclusion in integrated models and methods in use in the single NMSs. And you have, of course, numerical models which are more or less used by all the NMSs, but in this I'm really sure that there will be different models, different methods necessary for different institutes, for different needs. Now, let me show this expected way forward for the topic of convection. We had this initiation of convection as an important point. We had the life cycle and the weather activity as, of course, an important point for warnings, and the warnings themselves. Now, if we look into this initiation, this was the slide which I showed you already, and there were these blue stars where there is already the satellite input. From MDG, we expect to have also input from CAPE and SYN with the sounder. And precipitation is something which at the time being cannot yet be used in our Inca model, so the data are a bit too uncertain, or they are so different from grid point data from models that they cannot be used at the time being. But the HydroSAF has a big chapter of precipitation, so already before MTG we hope that something will go on there. Now the life cycle and the weather activity. Today we have the evaluation of typical structures, but the goal is to detect them automatically these structures of overshooting tops and ring structures. You remember this image which I showed to you with all the institutions working on this. By the way, this is from Martin Setvak, the Czech protagonist in this, and he gave it in the Humitrain Convection Week, this presentation. So this is a qualitative image. And it would now be necessary to use it quantitatively in the project to have quantitative automatic detection. And I heard it for the first time in the last UMETSAT conference in Cordoba, that those evaluations are already going on. These are the authors, mainly I guess from US, and they are detecting automatically the overshooting tops. They are detecting automatically the ring structures. And when I said to you in the beginning that we have worked many years on automatic detection of structures in the satellite image, I was very pleased when I saw this, because we were looking into the synoptic scale. They are looking in the very small scale, but they are using the same methods. They are looking into the single pixels, and they are looking how high the pixels are, and if you have lower pixels around to find the tops. They are looking into those points and looking into circles around where the values are higher and so on. So I'm very convinced that this will, in the next years, be a way forward. If this automatic detection of convective features like overshooting tops and ring structures is available, then we need a second point, something which is also ongoing, especially in our neighbor countries of Croatia and Slovenia. I know the colleagues from there. They are making correlations to hail and to wind gusts, especially to hail, of these ring structures, of these structures. So if we have really founded correlations, then we can really use it as a warning to the forecaster, at the forecasting with the cloud motion vectors, and then a warning to the customers, beginning with civil protection, but in the end to everybody. And now I'm coming back to this last slide, which I showed here. And I'm sure that we have also for the thunderstorm analysis then an input from the satellite data and also in the hail analysis from this automatic detection of structures and from the correlation to the hail and gust features. And the gusts is something which is really a problem. We had this line here. This gust line here was a perfectly forecasted, automatically forecasted thunderstorm and hail line. But it included something very heavy, namely downburst, and this downburst was not forecast in right time. It was forecast, but far too late. So we can make also a conceptual model. The downbursts are connected to thunderstorms. And if we include these automatic detected features and the correlations, then we can follow this way on again, and we see that, that the inclusion of satellite data in future to this automatic warning, even for gusts, for the gust analysis, will be possible. Of course, this is not existing. There are only elements existing, but I'm very sure that we can combine these elements and that we can bring something further in this period of the next 10 years. This is also something which I wanted to add. Also, I do not yet have really a good solution. Dust and volcanic ash, because it was a situation for Europe with Iceland, the Iceland volcano. This was the image which went through the media, through all the forecast offices and through the media in the very beginning. It was more or less the first visual sign to see this volcanic ash here. And many of them, also we, used this here to compute trajectories. But then, after some time, there were also computed these dispersion models, and of course they showed quite a lot, and there was a lot to conclude for air traffic. If correct or not correct is something which is not to decide by me. But these are two things which are apart from each other. So what we have today is the information from the RGBs, and it's the otherwise the trajectories in the dispersion model. What we need is to integrate this. And this is now a bit challenging because I do not know an answer at the time being, but I'm sure that there can be something. Height allocation was the biggest problem in these forecasts, and the connection with the dispersion models, and then the warnings to the forecaster, and then the consequences to the customers. Now, this was now from the future, from satellite image, and the red line which I want to put through all this is that we have to include the satellite data into the models and methods, not numerical methods for the forecaster. But we have to ask also, will there, in this period 2010 to 2020, be still a human forecaster working as forecasting. And after I brought this yesterday, I had quite a lot of discussions afterwards with many forecasters. And there were different groups, as I will show it now to you. There was the first group who says, no, the numerical model will be perfect in this time or close to this time, and they can do it much better. And if a forecaster wants to amend them or to improve them, he will not be right. He can only make a forecast worth. And the second group is, of course, the group who says, but we have the regional knowledge, and even if models have a very high grid resolution, they cannot. I'm coming from this mountainous country, and for some of these areas, this might be right also in future. And then there is this third group, which sees a bit more around forecasting and models. And the group says, yes, there will be human forecasters, but they might have to concentrate on different things. The human forecasters have in their brain a very detailed and a very interlinked image of the situation. They can combine different situations much better than a model, and they can also look into the surrounding, which is partly non-meteorologically, but important for forecasts. For me, it's something like a neural network, a very good neural network. And so if he has his comprehensive picture in his head, it should be used for much more than only for adapting numerical models. And every time I say to my forecasters, it's not worth to say it's not 7 degrees, it's 8 degrees. This doesn't mean anything for the forecast. But for what should it be used? In catastrophic, or let me say very critical weather situations, the meteorologist is a partner of hydrology, of avalanche. This is, of course, something in the snow countries, of civil protection, who knows a bit more about these very complex situations and about what they need. And the meteorologist selects the most appropriate method. And if the most appropriate method in this case is to look into the features of a CB, of an MCS, then he must know that this is the outcome. And when we talked about NWP, when Thomas said there must be much more knowledge about this, I agree completely. They must know in a complex situation where they can trust, which method they can use and combine. And there's another point, the development of deep knowledge for the different needs of the different customer groups. And the customer groups, I have here some electricity companies are also a customer group here. The winter road services are not a customer group here, I guess, but they're very important in our country. Building industry, I think, is everywhere. Leisure industry and tourism. Agriculture, I think this is one of the most important customer groups with very special needs also here. Many more. And the meteorologist learns from these customers because when he sees what they need and how they need it and at which time they need what, he sees what he has to develop newly, what he has to combine, and he really can approach forward with this. This was an experience which in my department has made in the last years. In former times we said, yes, we have temperature, yes, we have wind, you can have it, and we put it to them. And now we are really finding out what they are needing. And we see that we have quite a lot in our basis, but many products are not yet appropriate and are not yet parent, have to be constructed. And remote sensing data are an input to this product. In any case, they are an input. Now, the forecasters must gain to use this a deep theoretical knowledge in model output. This was already said, and I can really agree to this. A knowledge and skill in interpreting the methods from remote sensing data, and the deep knowledge for the problems and needs of the customers. And now coming to the end, this knowledge has not only to be gained in one course, as you mentioned it, I think it had also to be kept alive. And this is even same important, because I know if you are doing duties and you are not using something for some time, you forget how to do it. So we have developed in the last years new methods of training, and it's especially this online training, which is possible through all these communication softwares like Centra and Illuminate, and you can really contact, you can put together with the whole world, discussing for 1 hour some subject. I know that usually universities, I'm here in a university, are a bit shy with this, because it's a very clear way to present this. But the one should not show the other way. The online training can be something for some topic to include the knowledge of others for 1 and the other hour. And also in an operational service, it's much easier to include it than the conventional ways of going to 2 weeks workshops. Well, longer courses for bigger topics, for instance NWP, are something which is already partly provided by Imagery. Smaller information blocks are ongoing every time. You train. I will summarize all these training projects to you now. About topics, about smaller topics, about event weeks is also something which is ongoing. And I know that in many of our presentations of Train, we are not yet so far to the east, but I'm sure that with our new visualization system, we can also do, and we invite you to really search for this. And these new communication methods for training have to be become a part of the operational duties. I said it already yesterday. So my dream is that we have like a TV program, where you can find short presentations to topics, what 1 hour presentations are going on. And it's another point also, if you are going to these presentations, if you are participating in them, you see which other, on the whole world, with other participants are here. If we have our event weeks in Train, Convection Week, Snow Week and so on, we have, let me say, 40 connections, but behind every connection there are sitting up to 50 people. So we have, with one of these lectures, we have 800 people. And they are coming really from the whole world, and you get from time to time, you remember the name, you remember what questions they ask, and you get an international connection you never would have without this tool. And of course, a simulator training to keep the know-how, very small 10 minutes webcast where you have a library of this webcast which you can put out. So if you, for instance, have this ash cloud, it was the same in our institute. Of course, they have learned it once. But then the media were calling them. Why do you see it? What does this dark stripe mean? If you have a webcast or you have your connection, an online connection to a specialist, you can refresh it in 10 minutes and you can pass it over. And I think this has to be really a part of a forecaster's life to keep all these things alive. Now, there is already quite something of this existing. I'm very quick. This is the manual of synoptic satellite meteorology, the conceptual models. You have your web address, the mail address is here. This is Train, which is a training project. All things are free on web. This is the SATREP Online, and the SATREP Online is something where I really would ask you to look into it and to join it. There is an online discussion every month. And this is now our new visualization system, which is a new MedNet project, but I would be very glad if they would develop some cooperation. And with this, coming back to this remote sensing and future 2010-2020, I think a very big step has been done with each new satellite generation, and especially from MSG. But MSG, METOP, and NOAA are relevant in the biggest part of this period, so we have time to develop what we have already reached. Consequently, we have to improve and to consolidate the recent development. We have to continue the sequence from image to product, and we have to integrate the quantitative products in integrated models methods with really some different needs from different NMSs. And we have to develop the methods of automatically detect features and combine them in warning system. And I can again support this. I have worked with this training method many years, make training and international communication an operational part of forecast, and use and apply this online training and develop further these online training methods. And with this, I thank you very much for your attention.
One example that you show about the discrepancy between model forecast of temperature and PV advection and the location of the generation of clouds, like people know how they immediately maybe there's some estimation of latent trees, which is also affecting stretching effect and therefore PV and so on. So knowing how is also being allowing weather forecast to be more critical cloud weather forecasting product. One more point, regarding JSON tree, I presume you want to use satellite activity in order to derive geographic currents at the sea and then to improve your understanding of JSON. Yes, to the marine boundary layer. So this is the reason I apply. So I worked in the last 2 years with a piece of products of that, the activity and find most reliable, and I think that this is one that is missing, implement
I'm sure that this is something important for you. I must confess that I do not have much experience because Austria, being far away from, is not a part of this project. I'm fighting for this, and hopefully I will be successful in the next years. Thank you.
Well, thank you very much.